Hello and welcome back to Mr. Powers Teaches Algebra. Now in this video I want to go over a little bit more of these properties of exponents, but we're going to talk about rational exponents and how those relate to roots. Okay, and so this is again just a quick little lesson on this stuff here. Now hold on here. What am I? Why? There we go. Okay. So let's say, and I think actually I want to zoom in here a little bit. Forgive me. Okay. So let's say that we need first and foremost. Hey, what does this mean? Let's say I have an exponent. Let's say b. What was that? B. Let's say I added something, say b. A little big. Let's try that. And I want to raise it to the 1 over n. B to the 1 over n. Now, what does that mean? You know what? Let's say for fun too. I don't know. Let's try to attack it this way. I'm going to say that's equal to another number a. Okay? Since we have some basic properties already, and we have this idea of algebra, this is an algebra class, and one of the most basic ideas in algebra is we can pretty much do whatever we want to one side as long as we do the same thing to the other, and an equation will stay true. As long as the things we are doing, they got to be certain things we can do. One of those things we can do to both sides of an equation and have it be equivalent, have it stay true, is we can raise both sides of an equation by a power. We can square both sides, cube both sides, and the equation will squaring maybe not, but in any case, we let's pretend like we can, because I mean, if we have negative 2 equals 2, well, that's not true in the first place, right? So actually, I was thinking negative 2, there we go. Negative 2 equals 2. Now, if I square both sides here, square and square, you get 4 equals 4. But, so what I was thinking was still not what we started with. So ignore what I was doing there. Okay? Let's just move on. Enough of that. So we do have this property that if we start with something true, that if we raise both sides of the equation by the same power, we will get something that's still true. So in this case, I can raise both sides of this equation by the nth power. Hold on one second. Let me do something. All right. I just wanted to change my colors. Okay. So we can raise both sides to the n. Well, what happens when we do this? What happens? All right. Well, what happens is we'll get on this side b to the 1 over n to the n. Well, what happens when you have a power raised by a power? You multiply these. And what's 1 over n times n? Well, that is 1. That's what that is. That is b to the n over n equals a to the n, which is the same as here. That's the same as saying b equals a to the n. So these are equivalent statements, what I started with over here and what I'm getting at over here. So why did I want to say that? Well, because if we look at this right here, what this means, like for instance, if I had something a little bit more basic, let's say I had 2, or actually, let's go with, oops, there we go. Let's say I had 4 to the 1/2 equals 2. Okay, and let's say I squared both sides. What I get is 4 equals 4, right? But I don't want to write it like that. What I want to write it like is actually 4 equals, because I write it like this, 4 equals 2 squared. Or I could have written 2 over 2 equals 2 squared, and so I get 4 equals 2 squared. Very similar to what I did just now above, but what do we notice? 2, something squared equaling something else, and this is a true statement, right? 2 squared equals 4. Well, that means 2 is the square root of 4, right? That's what that means. 2 is the square root of 4. And I could have done something else. I could have said, well, you know what if and let's go the other way. Because that might make more sense. 2 cubed equals 8. So if I raise both sides of this to the 1/3, what do we get? We get 2 on the left, because 2 to the third raised to the 1/3. Well, 3 times 1/3, again, we multiply the powers, is 1. So 2 to the 1 equals 8 to the 1/3. Maybe this illustrates it even better. 2 is the cube root of 8. What do we get? This is saying that the cube root of 8 equals 2. This over here is saying the square root of 4 equals 2. And right here, what we're saying is that the nth root of b equals a, because a would be the nth root of b. A times itself n times equals b. That is literally what it means to be the nth root of something. So all of that hopefully was clear. What I'm trying to say is that this statement right here, okay, and actually let's go ahead and slide over this way. What we're trying to say is that if I had something written like this, b to the 1 over n, that is equivalent to saying the nth root of b. That's a property we have. It's a very, very nice property. Now, if that's a nice little property we got, we'll just pop it. Well, then I can do one more thing. And I'm sorry, this video ended up being a little bit longer than I meant it to be. Where's my time? Okay. So we got one more statement that we can make then. Okay. If b to the 1 over n is the same thing as the nth root of b, that means that, I could go even further. I could say b to the m over n is the same thing as the nth root of b to the m. Why can I say that? Well, what's another way to write this right here? Well, I could just say that's b to the m raised to the 1 over n, because what's m times 1 over n? It's m over n. And that's how I get this right here. I'm taking the nth root, that 1 over n, raised to the 1 over n, the same as the nth root of b to the m. Okay? Now, but, you know what I could have done instead, all right, is say, hey, you know what, b to the m over n, what's another way to write that? I could have written it as b to the 1 over n raised to the m. What's another way? What's that then? Well, that's the nth root of b raised to the mth power. Both of these are perfectly fine. All right? So what did I do? I took this. Oop, what the? I took this, come on now, this right here, and I wrote it two different ways. I wrote it like this, and I wrote it like this. That is what we are getting out of this, is that if you have a fractional exponent, you could write it two ways. No matter what, though, the denominator, okay, the n here, the denominator, was the root, and the numerator is the power. That's what I'm trying to show. Okay, and that's enough for now. And I will make another video where we're going to take this and explain a couple other properties that we'll have and then do some examples by hand. So stay tuned. Till next time, have fun doing math.